In this week's unit, we are talking about algorithms. We're going to be thinking about a couple really famous ones to practice some of our coding and get a deeper understanding of how we can work with more complex algorithms, but also just to kind of deepen our understanding about algorithms in general. And then you're also going to do a little bit of research and exploring on your own about another famous algorithm of your own choosing, and then try to solve one that's a bit more relevant to your own life. But for now, in this video, I want to just kind of help us understand a bit more about what an algorithm is, and also give you an overview of the two famous algorithms that we are going to be learning about in the next videos, how to solve completely. An algorithm, by definition, is a sequence of finite, meaning it actually is solvable, there's actually a solution that's reached. Well-defined, meaning that it's actually intelligible and clear instructions that solve a problem. We could think of an algorithm as something that we could explain to another person in real life. Maybe I can give some advice to somebody to say, if you want to do better in computer programming class, follow these steps to do so. First, study more. Second, stop playing games while you're trying to code. And third, maybe get more than 2 hours of sleep. Maybe that's just kind of life advice, but you can think about structuring those things together. Get home, sit down, turn off the video game, and open up the IDE. Then focus for 3 hours, then close things up and go to bed. Get some sleep. Repeat the next day. That's kind of a small, simple algorithm that could help you improve your results in a course like this. But in the world of computers, we want to be a lot more well-defined and precise about things. We actually need to represent the logic that's required to solve the problem using our coding language. And often, the reality is that a given algorithm, particularly if it's complex, might have many, many different ways of resolving it to a final outcome. And so there's lots of room for creativity and unique ideas in this world of algorithms, although those who work a long time in the field often kind of come to settle on, for common famous problems, maybe a best practice for how this is implemented. Maybe in the world of computer science, a great or best algorithm might be the one that gets the answer the most efficiently, or with the fewest steps, or with the least computational power required. So what a good algorithm is might be a little bit different than just a general algorithm, but the idea remains that it's a well-defined set of finite instructions that solve a problem. And we want to practice our algorithmic thinking because the further along we get in our study of computer programming, the more and more we're working in the realm of algorithms, and the less we're working in the realm of just knowing how to write the language itself. At some point, hopefully soon, it becomes kind of, well, maybe you become fluent in it. It becomes kind of second nature. You're not really looking up stuff so much. Maybe you're even thinking about or dreaming about things in the language of computer science, in algorithms, the way that you format all of these different pieces of logic together. So let's cover two famous algorithms. Just want to describe them to kind of set the scene before in the future videos I show you a solution that maybe you could find a better version of to these algorithms. And the first one, let's pull this up here, is called the birthday problem. The birthday problem. Oops, with a B. And what is the birthday problem? Well, consider the scenario where you are in a room with other people, which might be kind of a rarity in this day and age, unless you're watching this video in future years. And you're just kind of having a conversation and going, what are the chances that any of us share the same birthday? So maybe this is you, and you go, my birthday is May 3rd. What are the chances that somebody else shares this birthday with me? Well, maybe you begin to think, okay, there's 365 days in the year, and so my birthday is on one of those 365 days, and their birthday is on another one of those 365, and theirs is on another of those 365. So something to do with the probability of 1 over 365 maybe added together or multiplied together in some combination. And okay, maybe you have some kind of a guess. In fact, try to make a guess or prediction in advance before we do the algorithm in the next lesson to kind of see if your intuition is correct. But what we have the power to do in computer science is not just imagine a system with 3 people, but we can imagine a system with 4 people, or 5 people, or 1,000,000 people. We can consider all sorts of different scenarios and run some experimental tests. If you're a mathematician, you might think of the core principles of probability theory and actually run some very specific and precise calculations that would get you to that final answer. You apply some formulas, you use the kind of the well-documented principles of probability theory to calculate the exact answer to this. However, us computer scientists, although we do love math and we do implement it at times, we kind of like to avoid it whenever possible. And so what we're going to do with this algorithm is we're actually going to run this experiment in real time. In real life, this would be difficult, especially right now where we can't meet too many people. But imagine being here in the classroom. I could have all of the class, maybe 30 people, stand up, and then each person shout out their birthday. And then we see if there's any matches. So in a room of 30 people, do we get a hit or more than one hit? But the problem with that is it's just a single instance, a single run-through of the experiment. The number of trials is limited. So maybe we go to the classroom next door, and then the other one next door, and we go through the whole school and ask all the 30 or so classrooms to all do this experiment, and then we have 30 pieces of data that we can measure. And maybe of those 30, just completely random number, what if in 5 of those 30 classes we had birthdays overlapping? 5 out of 30, 1 out of 6. So is the number with 30 people 1/6 of the time? Well, maybe it's getting closer, but we want to run this experiment as many times as we can, because then we're going to get the best data on this. And I would like to run it in small rooms full of only like 2 or 3 people. I want to run it with rooms full of 200 people. I want to run all sorts of sizes and times so that I can get this massive data set. And then if I look at the data, I'll be able to see exactly when there is an overlap of birthdays in a range that I'm looking for. So the birthday problem is usually phrased as how many people need to be in the room before there's a 50% chance of at least one person sharing a birthday with one other person. So lock in your guess. How many people do you think need to be in the room? 365 days. Is it, for a 50% chance, is it half of that? Is it some different number? We're actually going to prove the exact answer to this, or close enough to exact. Exact is what we're willing to be patient for. We'll see in the next video. In that next video. But for now, lock in your guess. While I erase this and set us up for the second problem that we'll be working through. This one's called the optimal stopping problem. And here's the scenario that we need to consider. At this phase in your life, you might be interested in another human being romantically. I don't want to make any assumptions, but you just might be. And maybe you've dated a little bit. Maybe you're still waiting for that special someone to meet and kick things off. Maybe you spend too much time playing video games and you've ruined your chances. I don't know. I'll let you judge that for yourself. But what's happening in this scenario is we're considering, how do we know when to lock down the one that we want to spend the rest of our life with, if that's something that you're into? So I might consider person number 1 that I meet, and we fall for each other, we go out together, we consider ourselves dating, and then things just don't work out. So I move on to person number 2, and I like them better already. We connect in better ways, we have less fights, and the relationship lasts a little bit longer, and I go, is this the person that I kind of want to lock down? Or, because they're better than person 1 was, but what if there's someone better for me out there? What if there's some magical person that I'll meet, my soulmate, that one day will fall madly in love and everything will make sense? So you dump them, and you meet person number 3. And you're like, this person's worse than number 1. We had a little bit of chemistry, we tried it out for a couple days, and person number 4. And this person is the best one yet. And it's like, man, I know that if I commit to them, maybe they seem pretty into you, then maybe this is amazing. But what if? What about all these other potential people I could meet? Now, in this scenario, we need to kind of limit the possibilities in one kind of constraint that makes it a little simpler to solve this, which is if you dump someone, you cannot date them again. They're gone. You broke their heart, and they're not going to forgive you. It's a different calculation if number one, you're allowed to kind of go back to later. But right now, if you dump them, they're off. And the question is, at what point should you stop looking for more options, examining more data, dating more people? This is often phrased in the idea of hiring people at a business. How many people do you need to interview before you're ready to decide on who you want to hire? Because if you get 1,000 applications, maybe you only have enough time and energy and desire to interview 20 of them. And so maybe you do your best to prune down to the best 20 resumes, but when you bring them in, well, is there a point at which you meet someone really excellent and you just want to offer them the job right now before they get picked up by somebody else? How do you know when to stop looking for the optimal solution? And data science can actually give us some interesting answers about this that you might find to be useful for decisions in your own life. That's up to you to decide. But we can actually create an algorithm that's going to allow us to examine a whole bunch of different scenarios of different mixes of people and states, run a whole bunch of experimental tests, and then extrapolate from that final data where the optimal stopping point might be, the optimal stopping point. So I'm going to be able to tell you statistically what is likely the right number person that you date that you're going to marry. Not guaranteed, but just statistically the most likely one. That's what you signed up for in this class, right? You hope for this kind of deep data-based relationship advice. I know, you're welcome. So these are the two problems that I'm going to help you kind of learn about how to set up and solve before you go off on some of your own research and implementations, exploring algorithms in a bit more depth. Hope you find it interesting and valuable, and I'll see you in the next video as we look at some code to solve these two algorithmic problems.